Hi, everyone. I wanted to spend some time going through some of the things you're going to see in this week's lesson. In Unit 4.05, you're going to learn about the if, else, if options. So, what I decided to do was run a little simulation. We're going to use random numbers to simulate flipping two coins. We're going to say, if I generate a random integer 0, it's going to stand for two heads. If I generate a random integer 1, it's going to stand for one head, one tail, which would also stand for one tail, one head. And if I have a random number 2, that would stand for two tails. So I'm going to use the random number generator and then cast to be an int to generate these numbers. And every time I run this, I'm going to go ahead and print the value of r so you know what it is. Now, if r equals 0, I want it to print two heads. And then I'm going to say else if r equals 1, then I'm going to print one head, one tail. So if I'm not 0 and I'm not 1, I would say else print two tails. Now, you could put else if r equals 2, but that would be redundant because I know I'm not going to have any other conditions. So I'm going to run this a couple times so you can see. So when r equals 0, like we said, it would be two heads. And I'm going to run it so we see all the results. When r equals 2, it should be two tails by default. So the only one we really haven't seen is r equals 1. And there we go. When r is 1, we have one head and one tail. My best words of wisdom is to make sure you're using curly brackets that go with each one of your conditions. And then you'll never get confused with which code goes with what condition, where it stops and where it ends. So I'm a big advocate of using the curly brackets. So what I'm going to do now is I'm going to actually comment this part of the code out so it doesn't interfere with the rest of our exploration here. So I'm going to go ahead and get rid of this. And then I'm going to, so that should uncomment the rest of this stuff. All right, so now we're going to take a look at equals and compared to. So let me get rid of this, make sure it compiles okay. All right, so let's see what's going on here. I've created a bunch of string objects, apple, banana, orange, and then another banana. So try to remember that 1, 2, and 3 go in alphabetical order, and 2 and 4 are the same. So now if I compare, if I say object 1 equals object 2, it doesn't. So this condition should evaluate false. So it should print that this not statement. But if I compare object 2 with object 4, they are equal. They're the same objects, string objects, banana. So that should print object 2 equals object 4. So I'm going to go ahead and print that, and you should see. So the first one, they're not equal. The second one, they're equal. Then what you see is a series of compare to statements. So the way compare to works is if they are the same objects, when I say object 2 compare object 4, which they are equal because they're both banana, then this is going to equal 0. Now, recall that object 1 is apple and object 2 is banana. If I compare object 1 to object compared to object 2, since A becomes before B in the alphabet, this is going to evaluate to a negative number. But if I switch around the command and I say object 2 compares to object 1, since B comes after A, B is greater than A, so to speak, I'm going to print a positive number. So I can see if I run this again, I see in the first case I get a negative number because A is less than B. I see case 2, since B is bigger than A, I get a positive number. And then when I compare two things that are equal, the number that is reported is a 0. So that's how we compare string objects. When we start working with other objects that we create ourselves, we'll have to define what it means for two objects to be less than, greater than, or equal to each other. Now, the last thing I'm going to go over today is some logical operators using and or. So I've made up a couple tests, test one and test two. So test one is 95 and test two is 82. So I come up with this Boolean condition. If test one is greater than 90 and test two is greater than 80. So you just learned in the lesson, in order for this to be a true statement, both of these have to be true, which they are. So when I run this, it should say you are going to pass. So let's run that and see what happens. You are going to pass. Now, if I change any one of these, let's say if I change test 2 to 72, this time this condition is false. So this whole statement's going to evaluate false. So this time it prints you are going to fail. Okay, very good. So moral of the story is both of these have to be true in order for this whole condition to evaluate true. Now, the big difference between and or is that for an or statement, the conditions either both have to be true or just one of them has to be true. So if we look at what we have here, test 1 greater than 90 is true, but test 2 greater than 80 is false. But since it's an or, this evaluates to true, and this will print you are going to pass. Now, obviously, if I put this back to 82, both conditions are true. So we're going to pass. The only way I can get this statement to be false is if I make both of these conditions false. So I'm going to go ahead and do that and prove that to you. So now this is false and this is false. And if I run this, you are going to fail. Okay, so hopefully that's, additional examples for you in these lessons. Good luck. Try not to get behind. Make sure you're spending an hour a day and following the pacing guide. Thank you.